Welcome, everybody. Thanks for being here today. We're glad you could join us during a very busy migration season. We're at the height of migration for some hawk watches, like here in New Hampshire, where I am, where broadwings are starting to pour through. It's also International Hawk Migration Week, so I hope that everybody's able to get out and see some migration this week. I'm Julie Brown. I'm the Raptor Migration and Programs Director for HMA, and I'm facilitating things today with my colleague Kat Lauer. She's the Engagement and Communications Coordinator. And we're very excited to welcome Jessy Wilson. She's a Raptor Biology Master's student from Boise State, and she's going to be talking about her goshawk research. So before we jump in, I will just tell you a little bit about HMA if you are new to our organization. We're a nonprofit that provides support to the raptor migration monitoring network across the Americas. There's just over 200 Hawkwatch sites throughout North, Central, and South America, and they monitor migration during the spring and fall and report those data to our database hawkcount.org. And we provide resources to the monitoring network, standardized protocols, data support, a number of annual grants for Hawkwatch sites and raptor research. And we offer educational resources to the public, and we are an active partner in the Raptor Population Index, which is a program that produces conservation assessments and population trend analyses using all the long-term migration data sets in hawk count. So you can learn more about what we do at hawkmigration.org. We are recording the presentation today. We were having a little trouble with the live stream, so we're not live streaming this one. But you can view any of our Lunch and Learn programs on our Facebook page, or not this one actually, but afterwards on our website under the What's New section or under our events and tours tab. We are muting everybody today just to avoid distraction, but we love to connect with all of you. So we encourage you to write questions for Jessy in the chat. Kat will read those questions at the end of the program. So feel free to do that, make comments. You can chime in and let us know where you're joining from today. And lastly, if you don't already receive our e-newsletter that goes out a couple times a month, you can write your name and email in the chat or send it to me directly. And that's a great way to just stay up to date with HMA news and upcoming events. So I'll turn things over to Kat, who can introduce Jessy.
Thank you, Julie. Hello, everyone, and welcome. It's my absolute pleasure today to introduce our speaker, Jessy Wilson. Jessy is a master's student studying raptor biology at Boise State University. Before reaching her current progress in her graduate degree, Jessy spent several years migrating to places where she could study raptor species. This includes California condor recovery efforts in Southern California, Arizona, and Utah, snail kite breeding monitoring in the Florida Everglades, hawk migration banding in Minnesota and Idaho, and golden eagle nest monitoring along the Snake River. Thank you so much, Jessy. Please feel free to begin when you're ready.
Thanks, Kat, and thanks, Julie. I'm grateful to be here today and to get to talk with you all about a really cool bird. And thanks to everybody who is tuning in online. I want to start off the talk by saying I'm here today, of course, to talk about a very captivating bird, the mighty goshawk, and specifically a very special population of these birds. And I hope to do them justice in my explanations of why. I am also just one of many when it comes to this specific goshawk population in the northern Great Basin. And I just wanted to give a little shout out to IBO Team Goshawk and all of the people over the years who have dedicated time and effort to understanding this population better, all the way back to the 1990s until now. And yeah, just a broad like structure of my talk today. I'm sure that I am presenting to quite a lot of people that are familiar with the American goshawk, but I'll start with some background information and then go into the northern Great Basin population in particular and touch on my current thesis research as well as my next steps for that. So to start, the American goshawk is a large hawk, lives in boreal and temperate forests throughout North America. They have a reputation for being an adaptable and aggressive hunter. They're both good at chasing prey through dense forest as well as out in open areas. I'll touch more on diet in a little bit, but generally they hunt a variety of avian and mammalian prey. As for their species range, many of you probably know that they were split as a separate species from the northern goshawk a few years back. So now it is American goshawk and Eurasian. So this is the range map for American goshawks, and their general habitat tends to be mature forest, and this can be a variety of forest types. And they occupy forest edges as well as interiors, and they can be found at various elevational gradients throughout their continental US range. And the breeding range also overlaps with their year-round range, which is why there isn't the orange breeding range on this map you see, because many individuals are also residents throughout their breeding range. And this species is partially migratory, although most adults do tend to stay more residential, especially in the West. A portion of individuals do migrate and overwinter in areas outside the breeding range, and migrants can travel varying distances, often going to lower elevation areas or more open habitat. And of course, this wouldn't be a goshawk presentation to hawk watching crowd without talking about goshawk eruption. These are really cool phenomena. They happen roughly every decade. And during these eruption years, there are higher numbers of goshawks migrating away from their breeding ranges, and they're traveling much greater distances as well. These cycles are driven by prey availability at higher latitudes, primarily snowshoe hares and grouse. There we go. And yeah, broadly, the population trends across the species range are complex. There has been concern over goshawk population trends since at least the 1980s, which has spurred increased conservation and management efforts. Goshawks face several threats, including loss of nesting habitat, unstable prey populations, as well as shifting climate regimes during peak vulnerable periods of their annual cycle. The raptor population index has shown significant declines in goshawk count numbers at participating fall migration sites, and goshawk eruption years haven't quite returned to the sizes that were seen in the 70s, 80s, and 90s. The American goshawk is listed as a sensitive species by the U.S. Forest Service in several Western regions, and this designation requires biological monitoring to assess several things, including the effects of proposed management actions in these Forest Service regions. Sorry. And for all of these reasons, as well as others not mentioned here, there are population monitoring efforts across this species range during the breeding season, including monitoring done in the northern Great Basin. So why here? These goshawks in the northern Great Basin occupy a unique portion of the species range. They're kind of located along an edge between breeding and non-breeding habitat. I'm going to refer to this study area as the Minidoka Ranger District, and this is a portion of the Sawtooth National Forest. And the Minidoka is situated at like southeastern Idaho into the northern Utah area. And I might call the Minidoka Ranger District the MRD or just the Minidoka. And this study area for goshawks encompasses a total of 5 forest divisions, and these forest divisions contain naturally fragmented forest, all of which are nested within the sagebrush-steppe ecosystem beyond the forest patches. Within the Minidoka, goshawks are also considered a management indicator species, as well as a sensitive species. And yeah, in the Minidoka, there are these naturally fragmented forests, and this is covering a relatively small geographic area relative to the species range across North America. And this area contains a large diversity of habitat types that are used by goshawks. And I think that this study area showcases some ways in which goshawks are really interesting and just full of surprises. And it's been a real pleasure to learn about this particular group of them. Pictured on the right is a stand of subalpine fir in a goshawk territory in the South Hills, which is one of the 5 forest divisions in the Minidoka. There are also other forest types present in this system. On the right is a Douglas fir stand and somebody actually climbing a tree for a goshawk nest access. And on the left is a goshawk nest in a Doug fir tree as well. There are also stands of lodgepole pine, and there are subspecies of lodgepole pine in the study area, Rocky Mountain lodgepole pine. And there's also aspen stands and mixed conifer and aspen. And on the left, I think, is a cool shot showing an aspen nest that's also decorated with evergreen from lodgepole pine, I believe, in this instance. Excuse me. So, given their status as a management indicator species in the Minidoka, this requires biological monitoring, which researchers at the Intermountain Bird Observatory with Boise State University have been studying for decades, since the early 1990s. This monitoring includes annual territory surveys, nest monitoring, banding of nestlings and adults, as well as band resites. And color banding is really powerful for this species. It allows us to observe individuals in future years without needing to recapture them. And this is one example of many. This is a color banded nestling from last summer, a purple band DV. She was banded as a nestling, and then this year she was resited as a breeding female in another forest division. Goshawks in the Minidoka Ranger District take advantage of prey that is available across the sagebrush-steppe high elevation forest ecotone. Their mammalian prey in this system consists mainly of ground squirrels, and in ground squirrels, it's mostly Belding's ground squirrel, but they also will hunt golden-mantled ground squirrels. And this ground squirrel prevalence in their diet is particularly high in 2 of the 5 forest divisions because these 2 forest divisions lack tree squirrels. Goshawks in the study area also hunt jackrabbits, cottontail, and snowshoe hares. As far as their avian prey, like other populations across the species range, they hunt a lot of grouse and woodpeckers, particularly northern flickers, in addition to large passerines like robins and occasionally corvids. Throughout goshawk territories, they use several plucking posts, and that is where I took these photos. Goshawks are, in addition to being aggressive hunters, they're also aggressive nest defenders, and they're opportunistic in the hunt. that they will do. And one example of this is Cooper's hawks. This was from an occupied goshawk territory this past summer, and I had to measure these feathers to confirm that they were Cooper's hawk feathers. And it's likely that a coop got too close to this goshawk's nest, and the parents took matters into their own hands and appeared to also eat it. They've also been documented to hunt owl species, particularly northern saw-whet owls, northern pygmy owls, and long-eared owls. So overall, within this study area, goshawk diet is variable by forest division and ultimately by prey availability. And in the South Hills, the largest and most densely populated forest division for goshawks, Belding's ground squirrels make up most of the total biomass consumed by these goshawks. And the goshawk diet in the South Hills is relatively low in diversity compared to the other forest divisions, and this indicates a strong reliance on ground squirrel populations. Belding's ground squirrels are only above ground for a few months every year, and they tend to emerge shortly after the snowpack melts, and this might have critical importance for goshawk reproductive success, particularly in the South Hills, where they rely on them more strongly. But in addition to ground squirrel reliance, avian prey abundance is also a strong predictor of occupancy for goshawks in this area. American goshawks in the Minidoka do prefer dense canopy cover for breeding, as well as open understory and relatively moderate slopes. Goshawks build their own nest structures, and they frequently will build multiple structures within a territory and alternate using on different years. Their nests are located at the base of the canopy, and this photo on the left is from a nest that I climbed into and just took a POV photo. So this is just what the goshawks see when they're in their nest. But they don't always need that perfect dense canopy cover. This is one of our really interesting territories, and it kind of defies a lot of like typical expectations that at least I had about where goshawks will live. In 2013, Rob Miller made a habitat suitability model for the Minidoka Ranger District, and it gave some new areas that it predicted might be occupied by goshawks. And Rob saw this area and thought it might be an error, but he went to check it out anyway. And sure enough, he found occupied pair of goshawks and a nest. And since then, it has become one of the most productive and consistent territories in the whole study area. This is in a pinyon pine. And yeah, this like whole forest structure is pinyon juniper. And once this territory was discovered, survey efforts expanded to similar habitat types. And while there have been additional goshawk detections in these areas, there has not been another occupied nest found yet. And the parents at this nest hunt consistently jackrabbits, and it's almost exclusively jackrabbits based on some nest camera diet analysis. Despite the risks that may be associated with this particular territory and the adults specializing in what we might consider subpar habitat quality for goshawks, birds from this territory have been resighted and recaptured. This is a cool example from the 2021 breeding season where one of the nestlings banded was actually trapped at the ghost shoots during fall migration. Goshawks in this study area are not exempt from the threats that I listed earlier, including loss of nesting habitat, unstable or declining prey populations, and shifting climate regimes during especially vulnerable periods of the annual cycle. And importantly, these threats are often closely intertwined, and it's hard to think about them separately. And in response to these threats, changes have already started to take place in the Minidoka goshawk population. there have been lower occupancy rates as well as declines in productivity as measured by fledglings per occupied nest. And there's also been an increased rate of territory turnover between years. And currently, the turnover rates in this population are above what is considered normal for a stable goshawk population. So there has been, of course, research interest in this population to explore what might be driving some of these trends. And of them, one of the big possibilities is reduced canopy cover. And I will list some possible mechanisms of this, but it's not an exhaustive list. Sudden aspen decline is becoming more widespread, and this is thought to be caused by water stress and drought. There's also been an increase in tree disease and parasites that will make these trees more susceptible to disease and die-offs. One example of this is this nest stand that was occupied last summer. And this is a photo that our team took on a smartphone. And this type of photo is called a digital hemispherical panorama. And it's kind of like a smartphone alternative to using a really complicated digital camera setup. So it's much more cost efficient for me. And we documented this canopy photo, and then I binarized the photo, and it breaks it into sky pixels and non-sky pixels and calculates estimated canopy metrics. So last year, this stand was at 77% canopy cover, and we resampled with new photos this past June. And at the time that we visited on this day, we didn't know yet, but there was an outbreak of Douglas fir tussock moths, which is actually a native species that has boom cycles. But when they have really big emergences, they have pretty significant impacts on the canopy of the forest that they're in. And we didn't know that they had emerged at this point, but you can already kind of see this difference in the color of the canopy. And it was calculated to have a slightly lower canopy cover value. And then we came back in 3 weeks, and we were surprised at what we saw. At this point, the moth larvae were everywhere. Most of the canopy was dead or dying, and there were lots of dead pine needles on the ground, and canopy cover was down to 66%. So it dropped around 7% in just 3 weeks and over 11% from last summer to this summer. And there are also documentations of losing other nest stands to pine beetle and spruce beetle die-offs as well. Fire is another obvious mechanism of losing canopy cover. And in the South Hills in 2020, the Badger Fire was especially devastating and burned through a lot of viable territories that are, of course, no longer used anymore. This is from one of those territories. Another threat to the goshawk population is reduced prey availability. And this can either be in the form of actual reduced prey numbers from disease. Ground squirrels are susceptible to plague, and jackrabbits can suffer from hemorrhagic fever. And it's thought that these might be some drivers of reduced prey populations. And there's also reduced prey availability as it's perceived by the goshawks. And so with ground squirrels that emerge after snowmelt, there may be a shift in ground squirrel emergence relative to when goshawks are hunting for a nest. And so delayed snowmelt may be leading to sort of a phenological mismatch in a tight predator-prey dynamic, especially in the South Hills. And then, of course, there's climate. And what I'm listing is far from exhaustive. These are just some particular possibilities that I've been considering with my thesis research. So with climate change, there are shifts in storm patterns, and there can be increased spring precipitation. And we have learned that in our study area, spring precipitation is detrimental to goshawk productivity, particularly cumulative rain or snow during the month of April. And sort of in the same flavor, altered storm regimes can also lead to both extremes of either increased periods of drought or increased volatility of storms that can impact nests during the nestling stage. This is a photo from the South Hills last summer in the middle of June, and just gigantic hail. And this is kind of the stuff that was falling on nestlings, and it hurt me. So it can't feel good if you're stuck in a nest. And then, of course, thermal stress in the nest. This is a unique climate pressure for birds when they're unable to escape it. Examples of this are incubating females, and they could, in fact, choose to leave their incubating position to go find refuge somewhere else. But that comes at the cost of the breeding attempt. And then, on the other hand, if they choose to stay and experience prolonged thermal stress, this puts them possibly at a compromised physiological state, which likely has carryover effects for how they can provision their young. And then, of course, thermal stress also has implications for nestlings before they're able to fly and escape. And so I'll kind of take that train of thought to go through a little bit of my current research. So others have been interested in this microclimate goshawk nest survival relationship. And in a study on Eurasian goshawks, researchers have found that forest cover was an important protector against inclement weather, and that this forest cover mitigated some adverse climate effects on goshawk nestlings. And they also emphasized the need for higher resolution microclimate data to explore relationships like this further. In addition, the study that I brought up with the Minidoka population in reference to this April precipitation having negative impacts on goshawk productivity, they also have emphasized the need for higher resolution nest microclimate data. And there has been a lot of emerging research on the importance of microclimate, and particularly demonstrations of how sometimes this coarse climate data that it's been the only option to use, like weather station data, might not be the most appropriate scale for understanding processes that are driven by more immediate factors. And I have kind of modified this conceptual diagram from a really great paper that was published last year that's kind of just showing the nested relationship of different scales of climate. And so on the far left, obviously it's showing a broad spatial scale, so like a large land area. And as you continue to zoom in, the factors that are contributing to the processes at the scale shown are different. And even though they're related and they're nested within these larger patterns, when you're looking at a goshawk nest, for example, canopy cover, sun radiation, increased exposure to like temperature extremes happen on a much smaller scale than what can be captured by something like weather station data. And we're seeking to address this research gap and get some nest temperature data for goshawk nests. To obtain this finer resolution data, we deployed 88 thermologgers last summer in known goshawk nest structures and left them up throughout the rest of last year and this breeding season. we were able to recover data from 87 of these units, which was a much better recovery rate than I was preparing for. So that was really awesome. And we now have like full year of nest temperature data for 87 nest structures. And this is just a photo of me downloading some data off of one of these thermologgers, and we did send them back up the tree after recovering data. So they're still out there right now getting even more. This is a snapshot of what that raw temperature data from the nests looks like. I just plotted all of the thermologger data here, and the colors are grouped by canopy cover percentage. So lower canopy cover are the like lighter pink values. And this really is just to like show kind of what it looks like. And the big advantage to having this data is now I have real data for what goshawk nest temperatures are actually like. And to my knowledge, this hasn't been collected before. So now that I have this data, I'm currently up to my neck in several different analyses for some of the following research questions. One of them being, how does nest temperature impact nestling survival? In this question, I'm framing nestling survival as the probability that a nestling survives to its fledging age, which is considered to be 42 days. And nest failure is relatively uncommon in nest with young, and we think that most nest failures, at least here, occur on eggs or just generally earlier in the breeding attempt, which is why I'm looking at nestling survival, because brood reduction is more common. You can see the change in nestling numbers for each occupied nest. This is the maximum number of observed nestlings per breeding attempt, and then this slide is how many were observed to have fledged. Another question I'm looking at is I really want to be able to use historical productivity data, because you might be able to think of more close to home examples of long-term monitoring projects where you have access to like a lot of past years of survey data with productivity and hatching dates and fledging dates. And so I really would like to be able to use this nest temperature data that I've collected and see if I can make a model that can predict temperatures for previous years that I don't have thermologger data for. So in order for this to work, I have to train a model on a portion of my real thermologger data and add in a lot of other variables that exist and are publicly available for all the past years that I'm interested in predicting data for. And so I'm hoping that that will give me some predicted nest temperature values for the years 2023 and back to like 2015, maybe even 2012 or 2011. And my hope is to use these estimated nest temperature values to examine the role that nest microclimate has had when considering past productivity trends as well. And we hope to, by doing this, make a clearer connection between the population trends observed as well as their potential drivers. And this last bullet point is more of an aside, but since we redeployed a lot of the thermologgers this summer, they're just out there collecting more and more data. And the more time that they spend collecting data out there, the more valuable that data becomes, because for the exact reason that I have to predict past years of nest temperature, they're out there getting more years of data as we speak. And that's just going to become really, really valuable for doing multi-year survival studies without having to estimate that temperature. And that's kind of where I'm like stopping my research talk for today. And I have a lot of people to thank. There are some people that this project couldn't have happened without. I didn't spend a lot of time talking about deploying the thermologgers, but it is exceptionally difficult. And Rob Miller, Jake Chase, and Michelle Jeffries were huge in making this effort possible. And with the Forest Service at the Minidoka Ranger District, Jordan Witt has been really helpful for getting us resources we need and extra hands when we need them. My graduate committee, including Dr. Jen Cruz and Dr. Allison Simler-Williamson, have been helpful for my statistical analysis. And Stacy Smith at the Raptor Research Center has just been a really helpful role for me in getting field equipment that I can use. And for the American Goshawk project, you might recognize this logo on the right. This design was made by Emma Renier, who you might know on Instagram as well. And Emma and Heidi helped promote my fundraising effort, which is how I was able to buy all of my thermologgers. So to anyone who supported this fundraiser, thank you, because this research is able to happen because of your support. And Boise State Research Computing, I would also like to thank, as well as the NSF Graduate Research Fellowship Program for funding me. And lastly, this is unfortunately a familiar story, but if you feel so led to support IBO's goshawk monitoring efforts, it would be valuable now more than ever, because there has been a lot of loss of federal funding, and anything helps to be able to keep this research continuing for future seasons. And here's the literature I cited, and thank you for your time, and I'm happy to take any questions.
Thank you so much, Jessy. That was really wonderful. I feel like I learned so much about American goshawks. We have a few questions I'm going to start with, but everybody feel free to ask more in the chat as we're going. Julie would like to know, are there other thermologger / nest temperature research efforts happening for American goshawks elsewhere in their range that you know of? And are there any for other raptor species?
As far as American goshawks, to my knowledge, no. And I am just going off of what I've seen in published literature. So if there are other like in progress studies, I'm not aware of them. And I don't think that there have been any thermologger nest temperature studies in Eurasian goshawks either. There have been nest temperature studies for other raptor species. I think lesser kestrels have had thermologger like eye buttons placed in nest boxes, and I think that that's also been done for American kestrels too, for nest box studies. But as far as like these platform nests in forests, I haven't seen as much published research for that.
Yeah, that's really cool that you're doing all this work. So Nora says, great talk, Jessy. So interesting. I'm curious in what ways you would expect temperature to be related to canopy cover. Would lower canopy cover mainly related to being more related to daily fluctuation in temperature? And are there any other potential effects?
Thanks, Nora. That's a great question. As far as canopy cover and nest temperature, I think that canopy has a really interesting role with forest temperatures, and there are actually quite a few published papers on like just forest microclimate in general. And one of the concepts is that canopy can have sort of a buffering effect on temperatures below the canopy. And I'll go back to my slide with the raw temperature plots because it kind of illustrates some of the points. So like lower canopy cover, I would expect to buffer temperature less. And so this might look like more larger temperature extremes. So these nest temperatures might record higher daily maximum temperatures and lower daily minimum temperatures. So it's getting hotter and colder. Whereas if there is a like more substantial canopy to like shelter this temperature fluctuation, I might expect them to see less extreme peaks and lows. Um, yeah, I can't remember if there was another part to that or if that was the whole question. Sorry.
She did say any other potential effects of the lower canopy cover, I guess, or
Yeah.
temperature, I think, as well.
Um, oh, well, lower canopy cover would probably contribute a lot of exposure to inclement weather, so particularly precipitation. And the study that I mentioned with the forest cover and productivity with the Eurasian goshawk was talking a lot about precipitation and how canopy cover is sheltering nests from those events better. So,
Do you find, this is my question, do you find that there is a lot of fluidity? I know you mentioned that American goshawks often build multiple nests. Do you think that they're able to kind of adapt in their selection of those nests, or is it going to be kind of too unpredictable for them?
that's a really good question. And I think that my committee and I discussed like whether to focus on occupancy, which is more of that nest selection in the like initiation stage. Um, and I think that it warrants its own like dedicated research to look at factors that might influence how goshawks are selecting these nests. It is really funny how the birds in this population, at least, do sometimes choose their nest trees because within a territory there are like lots of instances where there's this beautiful like mature lodgepole pine and it's like in a nice lodgepole stand, and instead of nesting in that they're going and building a new structure in this wimpy little aspen that's just outside the lodgepole stand. And I think there's a lot more to be understood about the decisions that they're making when they're picking these nests and building new ones. And yeah, I hope I answered your question with more uncertainty, but it's a really interesting thing to consider.
Yeah, I mean, it's so complicated and there's still so much to know. Um, Thank you. Lillian would like to know, well, first of all, she wants to say great talk. And then she wants to know, how do you deal with goshawk defense of nests when deploying these thermologgers?
I don't have any photos, but we wear so much head and eye protection. Um, so most of these thermologgers were actually deployed from the ground. So it's a really long and complicated and difficult process. But only in a few instances are we actually climbing into the nests to deploy these. And those are when we're climbing to band nestlings. And so uh, the goshawks can be really aggressive in those instances. And so we wear helmet, eye protection. We have this like really big, like long sleeve shirt that we'll throw over whatever we're wearing so that they don't rip our like field shirts and stuff. It's kind of a like heavy duty jacket. And we have to also be really mindful of the nestlings when we're entering that space because we want to make sure that nothing happens to them, even if it is just their parent swooping in on a dive. So there's a lot to that we have to be careful about when we're deploying the loggers, as well as making sure that they don't hit the loggers while we're in the process of setting them up. So
I bet
yeah.
you're glad that they're still deployed, so you only had to do that once and you can get like multiple seasons of data from those efforts. Um, Lillian also would like to know, do goshawks prey on cassia crossbills?
They don't seem to take them. I think that they're like a little smaller than what goshawks tend to eat. Um, I haven't like heard of or observed any catch a crossbill predation. So yeah, it's nice that their range overlaps with these endemic endangered songbirds, and it's really cool to see them occupy the same forest space.
Absolutely. And then one last question. Oh no, there's another one coming in, but Dave would like you to hover on your references page so that they can see the cited papers again. And then Michael would like to know, how would you propose to mitigate the temperature extremes at the nest sites that you were seeing with your logger data? Are there any kind of interventions that you propose?
I think that for the mitigation aspect, the best long-term thing that we can do is advocate and recommend forest management strategies that will preserve existing canopy cover as well as like forest stand health. And so obviously these trees are subject to a lot of different risk factors on their own, including drought and parasitic species, disease spread, and some of that can be, uh, I guess, managed over the long term. But of course, it's not going to eliminate all risks to canopy cover and stuff that influences these nest temperature dynamics. Uh, One option that I've thought about is that there could be an effort to like manually place more shade structures when there's known occupied nests, but I think that the logistics of that would be challenging, and if the nest temperature is actually having a stronger effect earlier in the nesting attempt, so like during incubation, we like don't even capture a lot of that because of accessing these areas when the snow is clear enough for us to get there. So it might be kind of unrealistic to think that that might be something that can happen at the like nesting period that it's having the strongest effect on the birds. But I think the way forward will just be like advocating for management strategies that preserve forest health and just kind of seeing how goshawks respond to that.
Absolutely. Um, okay, one last question from Mary who says, wonderful talk. When was the last eruption?
They so I was at Hawk Ridge in 2020, and I remember that being a pretty like relatively good year, and I think that the last eruption was like 2019, 2020. There was one in I think the early 2000s, but the last like amazing one that I remember hearing about was in like the 80s. But they
Wow.
do happen every decade, but the degree to which they occur has been smaller in more recent cycles.
Right. That makes a lot of sense. Well, thank you so much again. This has been really, really great. I'm going to hand it back over to Julie.
Thanks.
Thanks.
Hey, thanks, Kat. Yeah, definitely head to Hawk Ridge if you want to see goshawks. That is the place to see them.
Absolutely.
Um, that that was very, very cool, Jesse. Thank you so much. That was such an interesting look at microclimate, which we don't typically focus on, and I would think it's just incredibly important, just given how much our forests are changing, and with climate change, and it's so important to figure out how adaptable these species are. So thank you. Um, we are going to switch gears for next month for our lunch and learn. And we're going to be hearing from actually one of Jesse's colleagues, again, another Boise State student, master student. October 29th, we're going to hear from Sage Dale, who is going to be talking about her research with gyrfalcons and peregrines. So we will have registration coming up soon for that in the next few days. So stay tuned. And I just wanted to also mention that September is Hawk Count Month. Some of you probably familiar with hawkcount.org, our database that houses all the wonderful migration data. You can support your favorite hawk watch with a site sponsorship that are usually $100. They're $75 in September. And donations support the Hawk Count database and come with a complimentary HMA membership. So you can have your name on the Hawk Count site for a full year, become a member, and it's a great way to support raptor migration monitoring. So with that, thank you again, Jessy, for your time and sharing your research with us. And thanks to everybody who tuned in, and hopefully we will see you next month.